Welcome to Pipe Math Podcast. We are going to talk about how to estimate cost of pipeline projects, and for that purpose, I just want to show you on Pipe Math. We are going to utilize three modules. The very first one is profile generator. The second one will be the wall thickness calculation because pipeline falls in Alberta, Canada, so we'll be using CSZ at 662 for wall thickness calculations. And then finally, we'll be using the pipeline cost estimation module to estimate the project cost. So let us start from extracting the profile. Suppose generally you can see this is an existing right of way, and generally when we start a pipeline project, our preference is to follow existing right of ways. So in this case, we have drawn the line. Now we terminate the line, and as soon as we terminate, then you can see the profile, the meter, the KPs are here, and the elevations are given here. If you are happy with your data here, you can scroll it down. If you are happy with your data, then you can simply press the button download into Excel sheet, and you will be able to download it. So I want to take a moment to explain how to prepare the data to upload for hydraulics, pipeline hydraulics. And on the right side, you can see the data was extracted from the profile generator, and then column A and B were copied here, which is our standard template required to upload the data for pipeline hydraulics. And this is kind of giving you some flexibility, like you can change the wall thicknesses along the pipeline right away. We do have crossings and HDD, so for more precision you can definitely add your wall thickness. And if you are changing the pipeline diameter along the right of way, then you can also do that. So once this is done, you are happy with all the data here, then you can save it, and then you can upload this data on the pipeline hydraulics module. With that data extracted, we'll move to the next module, and that is the pipeline hydraulics module. This is for liquid lines, and here you can see that if you will say that add pipeline profile, then you say yes, then it will show you the choose file. I already uploaded the file here just to save time, and there is, and then you press the upload data. So all that data which is extracted from profile generator has been uploaded here. And if you the very first time you want to know what template you want to use to upload the data, then you can also use a download template where you can modify the data and upload it again. So in this case, this is a below ground pipeline, and we'll be using Hazen-Williams equation. In this case, this is a new material, so there is no insulation on this material, sandy soil with some moisture, and then soil temperature is 5 and liquid inlet temperature is 10 degrees Celsius. So wall thickness is selected, and then total length is roughly 10 kilometer. So before the commodity, we have selected gasoline. So all the other data is background data is already extracted from this software, and now we are just estimating that the desired flow shall be 250 meter cube per hour. So target pressure is 3000 on the delivery side, and there is a inlet pressure at the start of the pipeline is 4000 kPa. So it doesn't matter, the elevation doesn't matter when we are adding a profile. In this case, the gravity is here, the water density is provided, and now we will just simply run the software, and soon we will have the results. And you can see here the very last column is showing us the outlet pressure. So as soon as if there is a red text, it means that we are not meeting our targeted pressure at that zone, and in this case we are kind of going down in this area slightly less than 3000. So we can definitely, other than that, I don't see there is any other problem here. So generally the flows are acceptable for the line size we have selected and the design conditions we have selected. So we can look at the graph, and you can see this is a profile. There is a upslope and then there is a downslope. So here, if you will look at the pressure graph, you can see after the upslope we are slightly going below 3000 targets, right? So this is the zone which is showing red in our table. So overall calculations are fine. For 10-inch pipe, the design flows are acceptable. So if you want, you can export our results to the PDF, and then so far we generated the profile. We used that profile for hydraulics calculations, for the sizing calculations, and now we are moving to make sure to the next module, which just to make sure that our wall thickness is acceptable for the design conditions. And we selected different parameters for the pipeline 9930, full pressure rating for 600 class or PN 100 class, with the design pressure and grade 359. Wall thickness is here, 10-inch pipe, and then we're just selecting class 1. And if you press the calculations, run the calculation, you see minimum required wall thickness is 5.25, so 9.27 is more than enough. And then we can also check that there was 125 meters of elevation difference, and that is the same amount we can put here just to estimate that if we will be having any issue with the selected wall thickness when we'll be hydro testing the pipeline. So in this case, you can see the stress levels are not exceeding 55 or 56%. So we are good for the hydro testing as well. And then the flage rating, we don't have any problem. For the material selection is fine. We selected Cat 2 pipe. The minimum requirement for this application is Cat 1. So we are also safe here. And then bend calculations, I modeled for field bending it is 1.5 degree per pipe diameter, and then for shop bending 20D bands cold bending, and we don't see any problem with the bending. No excessive wall thinning is happening here. The next is the roping, and we are getting the roping radius. The buoyancy control, there are slightly issues with the buoyancy control during the construction case when there will be water in the trench, and then road crossing is fine, and then upheaval buckling is showing okay under the clay condition, but if you will change it to sand, then it is telling us that there is a possibility that buckling can occur, upheaval buckling can occur. So once we are happy with the calculations, we can press export, and we will have the report. And now we have the profile. We know that our sizing is good, pipeline hydraulics is good, and we know our wall thickness is good. So with that, all that information, we can move to our next module, which is the estimation of the pipeline. And we selected 10-inch. So FP coating, no internal coating, trucking is the mode of transportation. And so there are for CP test station installation, 3000 per station, and it will automatically calculate the number of stations. Ground bed is 25,000 estimated, and the software allows you to change as per your experience. You can always change the cost, and then wall thickness is selected here. So here this is something important when we are looking at the pipe, right, the pipeline right of way, you can see that there could be rough, there could be level, plain, and there could be slightly rolling and rolling, and then very rough, right? So in this case, here we have seen 125 meters of elevation gain, so we are calling it rough. And based on the rough, we are assuming that there will be maybe 2000 2 kilometers, like 2000 meters, 2 kilometers, rough terrain. And also there is a possibility when we have this kind of terrain that there might be some rocks where we'll be excavating, so that will also add some cost to the project. So again, we are assuming that 2000 meter or 2 kilometer will be, we have to deal with 25% rock. So, and then right of way for a single pipeline, 20 meter is more than enough. And then for STD, we are assuming that there will be 1 kilometer of major STD. Then bore crossing, assuming the duckbill, and then the tri-hawk, and then open cut crossing is 300, and water bodies crossing is 500. So we are not assuming any pump station here, but owner's cost is 10%. So because we are assuming the sharp bends, cold bends, not hot bends or induction bends, so 5%, 3 to 5% is good estimate or good range to estimate the bending cost on a project. And then there will be launcher and receiver on either side, and one block well station, and then engineering cost is 6%, and then engineering cost for the facilities is 10%, and more cost is 12%, and we can increase it to 15 to 20%. It depends on the cost, it depends on the location. So warning signs are estimated, and all ditch plugs or diversion berms, or even you can use this input to estimate for the buoyancy control weights as well. So with that information, we can press the button, run the calculation, and it will give you all the details, the total cost of the material, the total trench cost, and then total cost. Crossing cost is this much, and then you can see engineering cost for pipeline, and then engineering cost for facilities. So the total, other costs are also estimated here. And now you can see the total pipeline cost is roughly $11 million, and then cost per inch per meter is $119 roughly, right? So that is an estimate. So with that, we have, by using pipe math, you can see we were able to generate the profile, we were able to size the pipeline, we were able to make sure that the wall thickness is good for the project, and we were also able to calculate the class 4 level estimate for our project. So I hope you will like this, and if you have any comments, then please do not hesitate to contact us, and thank you very much.